Okay, so I'm going to do problem 13 on page 145, and this is from chapter 5 in chemistry. Page 145, problem 13. It says to calculate heating 235 grams of water from 22.6 degrees Celsius to 94.4 degrees Celsius. So I'm going to write down the things that I know. The mass of the water is 235 grams. My change in temperature, or it's heated from 22.6 to 94.4 degrees Celsius. So that means my change in temperature, and we'll just do that quick on the calculator. 94.4 minus 22.6, 71.8 degrees Celsius. So that's my change in temperature. It says it requires 7.06 times 10 to the fourth joules of energy. So my energy equals 7.06 times 10 to the 4 joules. Okay, so if the microwave frequency is 2.88 times 10 to the 10, 2.88 times 10 to the 10, and it says per second. Second raised to the -1 means per second or hertz. How many quanta are required to supply the energy? So for the energy, I'm going to just write that down again, is 7.06 times 10 to the 4 joules. So my question is, how many quanta? So I'm just going to kind of draw a line showing some of the different information that I'm given. Really, in this problem, you don't need all the information that they give you. So the equation you're going to use is E equals, and I'm going to put an N next to quanta because actually that's what the equation shows. So NHF. E is your energy. N represents the number of quanta, and this equation isn't really given to you in the book, or at least in your equations. It's not exactly this way, so that's why I'm just showing you where to put that N. H is Planck's constant, and F is your frequency. So we need to solve for N, which is our quanta, and our number of quanta. So really, we don't need the change in temperature. We don't need, energy is given to us a couple of times. We don't need the mass of water. So those things I'm just kind of crossing off so that we don't need to think about that. So solve for N. I'm going to rewrite my equation. E equals NHF. To solve for N, I need to divide both sides by H times F. So I can cancel my H, cancel my F's. So now I have N equals E over H times F. So now I can plug in those things because I know all of those. My energy is 7.06 times 10 to the 4 joules. Planck's constant is 6.626 times 10 to the -34. And my frequency is 2.88 times 10 to the 10 hertz, which is actually per second. So my units for Planck's constant is joules times seconds, and this is hertz, which is per second. So my joules cancel, my seconds cancel, and that makes sense because Quanta wouldn't have a unit. So I'm going to show you how I put this into the calculator. 7.06, and I do the second button and then the x to the -1 there. I'll do it again just so you can see. 7.06 second EE, that represents times 10 to the, and then you just put the number, the exponent. Now I'm going to divide by my the two that I need to put together there. 6.626 times 10, or EE -34, times 2.88 second EE 10, my parentheses, and there's my answer. I have 3.7. I'm going to round to the nearest tenth. 3.7 times 10 to the 27 quanta. And that's how you do number 13.